Well, my name is Julio Sepúlveda. I'm a postdoc in the geobiology group of Royal Summons. I'm an organic geochemist, and I've been working here for the last 3 years. And I'm broadly interested in studying environmental disruptions and the ecological responses over periods of time of very abrupt climatic transitions in Earth history, particularly during mass extinction events. And I've been also interested in looking at microbial signatures in extreme environments in the modern ocean, particularly oxygen minimum zones and some areas near the continental margins. So a couple months ago, at the end of February and early March, myself and a student from our group, Marie Giron, went to Tunisia. This is part of an international collaboration we have with a colleague from Spain, Laia Alegret, from the University of Zaragoza, and also with Professor Hedi Negra, who is a professor at the University of Tunis El Manar. The reason why we went to Tunisia is because there we find the most expanded and some of the best preserved outcrops containing information about the end-cretaceous-mass-extinction event. And as a matter of fact, the Stratotype section is actually found in Tunisia, which is in El Kaf. After some preliminary study that we did using a small sample set from Tunisia as part of a global screening of samples covering the end-Cretaceous, we found that these rocks in this area have some of the best preserved molecular signatures that we've seen so far. And organic content is relatively a bit more elevated than in most of the sections that we've seen so far. Preservation is really good, and they are thermally immature. But one of the largest advantages that these outcrops provide is that they are the most expanded sections in the world. So the boundary itself is characterized by the presence of a thick clay layer that in this region is about 1 meter thick. So if you compare with deep sea sediment cores, in open ocean sites, the impact itself, or the clay layer after the impact, is only a couple of millimeters or centimeters thick. So in this region we find it in the order of 1 meter thick. So that allows us to do a very high resolution sampling. Therefore we can get a very nice time resolution for studying what we want to do, which is the recovery of marine communities. So to give you a sense of the area that we were studying, so this is a map showing the northern region of in Tunisia. So we arrived in Tunis and we spent a couple of days there, but then we traveled to the northwestern region of Tunisia, and we were mostly working around the city of El Kaf, which is where the Stratotype section is found. So we spent about 3 or 4 days working in that region because that was the most important section that we wanted to target. But then we moved around and visited 2 other sections about 50 kilometers away from the city of El Kaf. So we spent most of our time working in those 3 localities, and they all have these expanded sections covering the Cretaceous-Paleogene mass extinction. And the difference between those different areas is that they were located at different water depths. So they also give us a nice sense of how the environment recovered at different locations, at different distances from the coast. And the final pictures that I can show you can give you a rough sense of the 3 main areas that we were studying. These are not the typical outcrops where you can just go and see like a wall and hammer rocks out of it. We had to dig a lot, so we had to dig like around 1 meter or so in order to get fresh material and weathered material. So this is more or less how the location looks like in El Kaf, Elis, and Ain Setara. And which is very nice is in all of these sections you observe the characteristic red layer, this iridium-rich layer that has all the chemical composition of the impact. And in this case, you can see this picture. It is surrounded by a layer, by two layers actually, of gypsum, which is a secondary gypsum. But in all of the sections, we have this very nice feature, which is, by the way, very, very helpful because it gives you a good sense of orientation when you are looking for the ideal spot to sample. And what I have here is a set of samples that are basically showing some of the most typical aspects of the extinction. So this extinction event occurred 65 million years ago, and it was caused, or this is at least what a large part of the scientific community agreed, it was caused by the impact of a meteorite that impacted the Earth, what is in the area what is now the Yucatan Peninsula in Mexico. So there's a large crater in that region which is called Chicxulub crater that's been associated, or it's been dated, and it matched the extinction event itself. So what I have here, it's a set of rocks showing roughly how this material looks like when you are below the boundary itself. So this is a sample from about 1.5 meters below, that it probably represents several tens of thousands of years, or even 100,000 years of time. And they're a bit lighter in color, more consolidated, because these are marls, and they have a higher carbonate content. And interestingly, in this region, which is in El Kef, the Stratotype section found in Tunisia, you find what is called the red layer, or fire layer, that basically contains all the geochemical evidence for the impact itself. And it's a layer that's been found all around the world, and it contains the elevated concentrations of iridium. That's been one of the key elements for describing the impact. And one of the most interesting aspects about this particular sample set, we're largely interested in looking at those rocks that were deposited immediately after the impact, because they contain all the information about the immediate response of the environment, of the ecosystem, to this large environmental perturbation. And so these rocks are slightly darker in color because they have less carbonate due to the extinction of many calcareous organisms, calcifying organisms. So they have a higher clay content. And as you move up in the section, you basically see that there's again a change in color and lithology. So we start having more carbonate again, but in this case they're still a little bit darker than what you find in the pre-boundary. So this set of samples is basically showing more or less some of the main lithological changes that we observe across this extinction event.